in math, when we're talking about the word slope, other words that have the same meaning of slope are things like rate of change. So rate of change is the same as the slope. Constant of variation is the same as the slope. Okay, so things like that mean the exact same thing as slope. So what we're actually looking to find when we're looking at slope is the actual degree that the slope of a line is. So we're looking at a straight line. How slanted is that straight line? So if I wanted to calculate the slope of these lines, first we need to know, well, what does slope actually mean? So what we're looking at when we're talking about slope is we're talking about how far a line rises divided by how far it runs. So rise is going up and down, and run is moving left to right. Okay, we're always going left to right. Okay, so if I was looking at this graph, this first graph, so let's find the slope, and slope is denoted by m. A lot of the times what you'll see is m equals delta y over delta x. Now what that is the change in y, the second y point, minus the first y point, over the change in the x, the second x point minus the first x point. So if I zoom in on this graph, and we were to try to find the slope of AB, okay, and we know that that's y2 minus y1 over x2 minus x1. What we can do is we can kind of do it two ways though. If we can actually see the graph like this one, I can just draw my lines. Now my rise here is going to be 1, 2, 3, 4, 5. So I've gone up 5 units. My rise is 5 over my run, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. My run is 11. So my slope of AB, it's a lowercase m and then uppercase AB denoting the line AB, is 5 over 11. And I just leave it as a fraction. Slopes as a fraction are actually easier than decimals because you can see the rise and you can see the run. Now, if we look at the second line there, so if we look at that second one, I'm just going to erase the dots here. So now we've got CD. So we're looking at the slope of CD. Now this one, we're going to go down and then over. We're going down 1, 2, 3, 4, 5, 6, 8, 9. Now, if 5 was positive and we were going up, that means down is just going to be negative, just like the coordinate plane. If we go below the x-axis, it's negative. We're going down. In this case, when we move down, it's going to be negative. Because when we go to the right here, we're going down. And then we're going over 1, 2, 3. And now 9 over 3 is negative 3. So the slope of CD is negative 3, or negative 3 over 1 you could write if you wanted to. So looking at the next graphs, the next ones are a little bit harder. Now the slope of, we'll do EF next. The slope of EF. Well, the slope of EF, if we look at our graph, it doesn't go up at all. So the slope of EF is 0 over, and we could do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. But 0 over anything is still just going to be 0. It could be 0 over 1. The slope of EF is 0. And that's the same for any horizontal line. So any horizontal line has a slope of 0. okay? Now, if I look at the slope of GH, now the slope of GH, well, in this case, we're going from -7 up to +8. So that's 15. I'm going to just put a line here so it kind of divides these two, because that's an important point up there. And this one's kind of important too. GH is going up 15, but it's not going over anything. Okay, now if I put that into my calculator, I'm going to get an error. Okay, so what the slope of GH is undefined. Okay, we get an error in our calculator because we can't divide by 0. And the slope of any vertical line, because we would be dividing by 0, the slope of any vertical line is undefined. So we're not going to actually write a slope in because it's undefined. Okay. Now, if I were looking at equations of vertical and horizontal lines, they're also a little bit more difficult to understand. And I'm going to write the equation of these two lines in here. The equation of this horizontal line is just y equals 2. It's at 2, so it's y equals 2. The equation of this line is going to be x equals -7. Okay, it's just x is -7. Okay, and I'm going to come back to that later, but I did want to point that out because that's something that people really struggle with. All right, so calculate the slope of these 2 points. So we know slope is equal to y2 minus y1 over x2 minus x1. It's the change in y, the rise, over the change in x, the run. Now all we really have to do is pick which point is 1 and which point is 2. And I'm going to show you that it doesn't actually matter which point you choose. So we'll go 1 and 2 this way. So the y value in point 1 is 5 minus -4, the y value in 2, over the x value in 1, -3 minus, oh, I did this backwards. So let's just change that to a 2 and this to a 1, because I want to make sure that I'm doing this the right way. Sorry, guys. I did that backwards. So, because we're always doing y2 minus y1, I did 5 minus -4. So that made these 2's, and it made these 1's. Minus 6. Okay, so 5 minus -4 is 5 plus 4, which is 9. -3 minus 6 is -9. 9 divided by -9 is just -1, or -1 over 1. Okay, now I'm going to do this again. I'm going to make this point 1 actually this time and this point 2. I'm just used to doing it the other way. Now the slope is going to be y2 minus y1 over x2 minus x1. Now in this case, we're going to get -4 minus 5 divided by, so -4 was 2, minus 5, divided by 6 minus -3. So we get -9 divided by 9, because 6 minus -3 is 6 plus 3, and that's -1, or -1 over 1. So it didn't matter which point we chose as x or as 1 or 2. We just have to make sure that we do it in the correct order both times. Okay, so what is the slope of this graph? Now, the biggest thing that people mess up here is the slope of this graph. They go 1, 2, 3. Okay, it's gone down 3. 1, 2, 3, 4, 5. It's gone over 5. Well, that's right, but it's actually gone down 250, 500, 750. So it's gone down 750, and it's gone over 5. So the slope is -750 over 5. Okay, now we can reduce that down. So we can do -750 divided by 5 and get an answer of 150, or negative 150, excuse me. Okay, now, but it says, what does this represent? And for that, what we need to do is we actually need to look at what our y value is and what our x value is. So what this is saying is the value of our student loan is decreasing by $150 per month. Okay, our loan is going down our loan goes down $150 per month. Okay, I looked at the actual graph to figure that out. Well, what's the initial value? The initial value is $2,000. It's right here. So it's $2,000. And it's representing the initial loan, or the starting value of the loan. Okay, it's always the starting value. Now, if I write an equation for this, well, my constant of variation, or my rate of change, is 150. It's negative 150. We've got y equals, because we know we've got a y value. And then we just have to put our initial value, because we're doing negative 150 plus the 2,000 we started with. So what we should start noticing, and every equation is going to be like this, is our equations are actually y equals m, our slope, times x, plus our y-intercept. Now what we actually do with that is we call our equation this: y equals mx plus b, where m is your slope and b is your y-intercept. Okay, so now we've got a new one. We've got, given the point A, so we've got our point A is negative 3 and 5. Draw a line that has a slope of 2, 3. Well, to do that, all I have to do is start at A, go up 2 to 7 over 3 to 0. Up 2 to 7, or to 9 over 3. And I'm done. Okay, I could draw that line. If you run out of space like I've done here, I can go back down to A, and I can go down 2, and then instead of going right, I can go left 3. Down 2, left 3. Okay, and now I can just connect my dots and put arrows at the end. You should always have arrows at the end of your graphs. That one's in blue. We'll do the next one in red. Slope of negative 5. What this means is we're always going down and then over to the right. If it's negative 5, really it's negative 5 over 1. So this graph's in red, so I'm going to go down 5 and then right 1. So I'm going down to 0 over 1. Down to negative 5 over 1. Down to negative 10 over 1. And if I ran out of room, we know A is at negative 3 and 5. I can go up and the other way. Now I can just connect all my dots. And there's my nice pretty graph. Now an undefined slope, remember, undefined slopes are always vertical. So all I'm going to do is go to A, and I'm going to just draw a straight vertical line at x equals negative 3. And there's my undefined slope. Here's some questions associated with this.